This is the second video review for taking a good random sample. And again, this video is just for people who are planning on doing a questionnaire survey of some sort, or if you're going to sit down and actually interview people, then you're going to need a random sample. If you are doing an experiment where you are actually imposing treatments, then you'll need to watch the video for experimental design. So in the first video, we talked about a simple random sample. So let's say I have a cornfield that I want to kind of figure out how much corn it's yielding to me and how much I'm producing. So what I do is I divide my cornfield up into 16 equal plots because there's no way I have time to get out and count every single piece of corn on this field. And what I want to do is choose 4 of those plots to get an idea of the average yield of corn in each plot. So because I have 16 plots, just doing the simple random sample that we did from the first video, if I number all of my plots 1 to 16, and since I only have time to really count the corn in 4 of those plots, I'm going to take a simple random sample of 4 plots. So I can model that simple random selection by going to math in my calculator, moving right to the highlight probability, and choosing number 5 for random integer. My lower and upper, I have plots going from 1 to 16. But out of those 16, I only want to choose 4 to give me the ones that I'm going to look at. So what this gives me is 4 numbers. It spits out, let me figure out what my calculator's doing here. I think I was in something I shouldn't have been in, so let me do that again. Math probability number 5, paste, there we go. All right, and that's going to spit out 4 numbers for me, and those 4 numbers that it spits out are 6, 16, 4, and 13. Okay. Now, my problem with the simple random sample for this particular example, if I was just wanting to choose people to talk to out of a population, then that would have probably been fine. But for this particular example, what I see over here on the right is I have a river that is beside my cornfield. And because I have this river, that may affect the results that I get from the corn growth. So I'm thinking because this is here, that these plots in this last column are probably going to get more water than these plots in this column right here. So what I would want to do then is I would want to take what's called a stratified random sample, and it's still a very good sample. It's actually still going to be parts of it that are SRS, but stratified means I'm going to break it into groups by likeness first, and then from each one of those like groups, I'm going to take a simple random sample, and that way I can assure myself that I get one from each different type of plot. So right now, as you can see in my simple random sample, this third column that probably is getting a good amount of water is not being represented in my sample. So what I'm going to do is I'm going to separate this out into 4 columns. And once I separate them by likeness, I have a column with a lot of water, I have a column with not so much water. Then once I've separated them into that strata, then I will take a simple random sample from each one of these columns. Okay, so this will look a little different. Now my numbers are not going to be 1 to 16 because we're going to be looking at this in a different light. So I'm going to erase these numbers and I'm going to renumber this according to the strata that I have assigned. So because I'm looking at columns now, we have 2 plots in column number, 4 plots in column number 1 that aren't getting a lot of water. We have 4 plots that are getting a little more water, 4 plots that are getting a little more water, and 4 plots that are getting the most water. And I'm going to take a simple random sample from each one of those columns. So now when I go to math probability number 5, I'm going to choose a number between 1 and 4. And I only want 1 from each section, because remember, my main goal to begin with was that I wanted 4 total plots, because that's all I have time to look for. So if I want 1 from each column, that's all I want is 1 from each column. So the first time I run this, I get a 4. So the first column selection is a 4. You can just hit enter. You don't even have to type it in again, and it'll give you another number, which is 1. So my second column will be 1. I'm going to go ahead and hit enter 2 more times because I need 2 more selections. So column number 3, it spit out a 2, and for the next run, it spit out a number 1. So I have 1 plot in every single column that I thought that water was going to make a difference on, and these are the 4 plots that I want to go out and count my average yield for. So that is one type. That is a stratified random sample. It is first grouped by likeness. So everything in that group separation is going to be the same. So if you're looking at strata, are those groups that have that same likeness, by the way. That's why it's called a stratified sample. So if you're trying to find out what freshmen think of the food service on campus, and the food services believes that men and women typically have a different opinion about that salad bar, then we don't want to just take a big random sample or simple random sample, because if we do that, we possibly could get a lot of men and very few women that way. So with stratified, I can group all the men together into one group and all the women together in one group. They are like, all the men are alike, all the women are alike. And then I can take a simple random sample of men, then take a separate simple random sample of women, and then I make sure I have an equal number of what I think is different in that sample. Okay. Now, another type of sampling you could do is called cluster sampling, and this, it gets confused with stratified a lot of the times because you're still grouping it, but this time you are grouping it first into mixed clusters, and then you only take 1 simple random sample to see which mixed groups you're going to talk to. So let's say I select and label all dorms on campus, and then I simple random sample which dorms to use, because most dorms on campuses, if they are co-ed campuses, most of those dorms are co-ed as well. So if I go ahead and look at a dorm as a mixed group, then I can just take 1 simple random sample and see which dorms I'm going to talk to. So just to clarify the difference between stratified and cluster, here is an auditorium seating, and I want to survey some high school students just in my school to see their opinion about something. And so when I have them come and sit in the auditorium, I put all the freshmen in the first row, I put all the sophomores in the second row, all the juniors in the third row, and all the seniors in the fourth row. So to do a stratified sample, random sample, then this is when I think the class you're in is going to make a difference in what your opinion is on my question. So I'm going to stratify by likeness first. I'm going to put all the freshmen in one group, and I already have them grouped all here in this first row. I'm going to put all the sophomores together in a group, all the juniors together in a group, and all the seniors together in a group. So we already have that sectioned out by rows. Okay, so to make sure that I get an equal representation, let's say I'm going to take a sample of 100 students from the high school, then I need to simple random sample 25 of them from this group, simple random sample 25 from this group, 25, excuse me. Take another simple random sample of 25 from this group, take another simple random sample of 25 from this group. Okay, so we'd have to run that 1 to 100 selecting, or excuse me, 1 or how many ever you're wanting to get. This takes care of all 100 of mine. So like if I wanted to make sure I had 3 freshmen in the group, then I would do 1 to 25 sample 3. So cluster is different. That's where we're going to mix the groups. So we're going to separate them this time into columns, because the columns are going to have a mix of everybody. So one group would be my first column where I have 1 of each type. My second group, same thing. So I'm going to go ahead and section them off by column all the way across the auditorium. Okay, and let's just say we had like 20 of those columns. Since these are already mixed up, if I wanted to talk to 3 of each type, then if I have 20 columns, I would run my random integer from 1 to 20, and out of those 20 columns, I would choose 3 so that I could make sure I have 3 of each type. So for this one, you only have to take 1 simple random sample, because if this spits out numbers 6, 10, and 14, then I'm going to choose row 6, or excuse me, column 6, column 10, column 14, and talk to all the people in those columns. Okay. So stratified is grouped by likeness, and then take a simple random sample from every single group. Cluster, group by mix, and then just do 1 simple random sample to see which mixed groups you're going to talk to. Okay. You also have what's called a systematic sample that you could use. So let's say, you were doing a survey at Walmart to see how many people had purchased something on a given day. I don't know. So every nth person on that alphabetical list or on that list would be picked. Now, what I can't do is go to Walmart and stand at the door and just say, okay, I'm going to talk to every 10th person that walks out the door, which is basically the gist of a systematic sample. The problem with that is that's not random. So if my best friend, if I could look in and see that my best friend was the 10th person in line, I could set that up and have some control over that to make sure that I talk to the people that I want to talk to. So if you're going to use systematic, you do have to decide where you're going to start randomly. You have to let the calculator choose that for you. Now, you can choose any number you want. If you want every 10th person, then what you would do to randomize it, is go to your rand int, tell it you're picking a number between 1 and 10, and you only want 1 of those numbers. And if it spits out a 3, then your calculator is telling you, all right, here's my line. All right, your calculator is telling you you have to start with the 3rd person. After that, then you can start counting and talking to every 10th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be the next person you talk to, and then you could keep that going every 10th person as they walk out the door. Again, you can choose any number you want. If you decide you want to talk to every 5th person, then all that changes is when you type in your randint. Then you're only choosing between numbers 1 and 5, and you just need the calculator to tell you which one you're going to start on. So if it spits out a 2, then the calculator's telling you you're starting with that 2nd person, and then every 1, 2, 3, 4, 5, I'll talk to her. 1, 2, 3, 4, 5, I'll talk to him, and then you can keep going with that every 5th person. Just make sure your calculator chooses which one that you are starting with. So that basically wraps up your different types of sampling methods. So if you don't think there's any reason for something to change an opinion, like gender or race or any issue like that, then just a basic simple random sample should be fine. But if you're looking at it and you really think something is making a difference in your answers, you do need to make sure that you either stratify or cluster to make sure that you talk to the same amount of people from each one of those groups. And then systematic is just another way. It just makes it a little bit easier to gather data, but at the same time does still randomize it. So I hope this helps you with making your selection on who you are going to talk to in your research.